Institute for Transport Studies at the University of Leeds, and I think he's going to talk to us about his work on new methods and open source tools for active travel planning. So yeah, whenever you're ready.
Okay, many thanks for the introduction, Clara, and hi everyone. It's great to be at GISRUK again. This was one of the first conferences that I went to as a PhD student, and honestly, it inspired me. It made me feel inspired to do research again, and I think that's partly because I was in my second year blues, and partly because no one was reading my work, let alone using it. So GISRUK is one of the most friendly communities of people that I've been to, so it's just great to be here, especially because Bristol is where I did my undergraduate, and I've got a lot of love for Bristol as a place to do research. So yeah, great to be here. I'm going to be talking about a methodological part of quite a big project. So as you can see, there's loads of people involved in this project, and there's a project called the Network Planning Tool for Scotland, which is funded by Transport Scotland. But this is really kind of zooming in on some of the methods that underlie this tool. You can't really separate the methods from the application in this case, because the methods were purpose-built for this application. So I'm going to talk a little bit about the project itself, but the focus is on the methods that we are using. And before I go into that, I just wanted to say this is also inspired by the idea of reproducible data science, and I presented this idea for a workflow for creating cross-language reproducible data science workflows in Prague several months ago last year that Martin coordinated, and as a little check to see that it is reproducible, if anyone wants to give it a go, I've uploaded the source code as you do to GitHub. It's GISRUK 2025 on my GitHub. A lot of people don't know this little button on GitHub, because it used to only allow you to download the repo as a zip file or to clone it, but you've now got this code spaces button. You've also got Copilot, which I won't go into, but if anyone wants to give this a go, you can actually open this up in code spaces, and that will fire up a kind of interactive version of these slides. And let's see if it works. You can then go into the terminal inside the browser window, and then hopefully just go Quarto preview, and it will preview the whole thing, but seemingly it works better if you do it with the slides. Hit enter, and then that starts running the code, and hopefully that will regenerate them. I'm just doing that because it's fun, but also I think reproducibility is actually really important to science, and the tools that are out there now for reproducibility are absolutely amazing compared with when I was an undergraduate here in Bristol. Basically, there was no way to run your code on any other computer than what you were given at university. So Richard Harris sat us in front of these quite clunky desktops that had ArcMap 3.2, and you went home and there was no way you could make a map again. And we're in a totally different world now, where you can install any software on your computer. Even if you don't have a high performance computer, you can run reproducible code in a web browser. And I just think it's worth taking a moment to appreciate how far the technology for making this kind of stuff super reproducible has come. So reproducibility is a big part of this, but I think nowadays that's kind of just how we work, or how we should work, but I just wanted to make that point up front. So that's a copy of the slides. This is the version that's hosted online. So I'm not going to read out the abstract, but basically this talk is about the work that we did to take data sets from different places and integrate them into a single place so that transport planners could better understand their transport networks and make better decisions based on that information. I think the idea that we need to improve the transport systems, I don't need to explain this to this audience, but I do have one little example which is a good motivation for me. So this was actually this morning because I stayed at a friend's house in Bristol.
There's a car there.
And they've got a
Okay,
4-year-old
this way.
daughter, and she actually cycled to school. Like, I think that's pretty amazing at the age of 4. So they're both on the way to nursery, and she's actually cycling most of the way. And how many people live somewhere where they think 4-year-olds could cycle
So good.
to school? Put your hands up if you do. Okay, that's
Well
actually more than
done.
I expected. I was expecting 0, so you've got like 4. Don't know how many people are in the room, but that's quite low numbers. And that is why I'm doing this research. I just think it's amazing that that is possible. It's certainly not possible where I live in Leeds, and Bristol specifically has made really impressive progress. So that's why I'm working on it, to make that kind of thing more possible. So I'm going to speed up now. So the result is actually deployed. It's part of a project for transport planners in Scotland. So that's like the end result, and I'm going to work backwards towards how we generated that. And if there's time at the end, maybe during questions, I can do a bit of a live demo of what it actually is. But basically, it's a web application for network planning to prioritise investment in cycle networks across all of Scotland. So in terms of how we built that, the good news for us is a lot of the decisions were already made for us. So if you're a software engineer or you're designing a research project, sometimes, ideally, the code should just be like your implementation of the ideas. The really hard bit is having the ideas. And the good news here is we already had a lot of the ideas that were embedded in policy, and this is actually a good document. It's called Cycling by Design, and it's basically the Scottish Government's Bible of like, this is how you build good cycle infrastructure. And in software engineering terms, you'd say that's the spec, that's the specification that we just had to implement. And there's a huge amount of detail in there, including a big table that links specific types of infrastructure, traffic volumes and speeds to levels of service, and we had to implement that, and that was a big part of what we did as part of this project. I've already said that the network planning tool is funded by Transport Scotland, so we didn't really have that much choice, unlike a lot of research projects where you kind of go out and you can be quite exploratory. They were quite prescriptive in terms of what they wanted, and in a way that was good because it means we could have a real focus on delivering it. I think a key part that I'd like to emphasize in this one is the integration of multiple layers into a single tool. That is really the element of this talk that is different from a lot of my previous work, whereas normally we've kind of focused on one of the layers, and usually, if you know some of my previous research, that is like the level of cycling potential on the network level. This tool goes beyond that by comparing cycling potential with loads of other things to help make the next step in terms of not just where do you build stuff, but what do you build, in what places, and what order do you prioritize your investment. And in terms of the technology stack, we did actually write a fair amount of code to do the project, and I'm very happy to say that some of it is totally generalizable. So the OSM active package, that is not specific to this project. This will work anywhere. So anyone who's doing active travel planning in any country can use this to add value to OpenStreetMap data, download it in a fairly computationally efficient way. And then there's another one which is called Anime, which is basically an algorithm that's implemented in the Rust programming language to give high performance spatial joins focusing on network data. And that was kind of the driver that allowed us to take the network information from multiple different layers and put it into a single visualization place. So I'm just going to focus on two of the layers here. So one of them is the existing cycle network layer, and that is shown here. So if you go onto the web application, you can look at the current network and then zoom in and basically assess what is there in your city. So the idea being, where you've identified gaps, you can fill them. So that's the existing cycle network layer, and that is mostly from OpenStreetMap, and I can talk a bit about that. The street space layer is the one that's definitely new, so that contains information on how wide the roads are, and it's one thing to say you need cycle infrastructure here, there's a lot of demand, but it's quite another to say, is there actually space to do it? Do you have to go down a different pathway? So that's the other one. And just briefly, in terms of the technical challenges to generate that street space layer, we had to combine three primary road network representations. Number one was OpenStreetMap, number two was Ordnance Survey master map highways, and massive credit to Ordnance Survey and Transport Scotland for allowing us to take derived versions of this data and publish it for policy purposes. And then the most detailed is OS master map topo, which contains the pavement polygons, and from that you can work out both the carriageway width and the pavement width, and get an indication of not just the width of the carriageway, is there enough space on the carriageway, but if you're willing to remodel the curb line and go onto the pavement, is there enough space if you are able to kind of change that pavement profile, while of course providing enough space for walking as well. So yeah, that's a summary of the input data sets, and I've highlighted in dark blue the ones that we used in this kind of network processing stage. There was also a demand modelling aspect of this work that used National Records Scotland, National Travel Survey data, and also integrated those. But the focus of this talk is really what we did on the network modelling side. So I've already alluded to the software. I don't have much time to talk about these, so basically go and check them out. They're mostly open source, and you can see them at github.com mptscot. So that is the project's home page where the code lives. And I've just described the tech stack. Probably one of the most advanced bit of code technologically is the MPW project, which is part of the MPT, and that adds an interactive front end where you can actually draw new cycle tracks and evaluate them inside the browser, and that's using WebAssembly. I didn't write that code, but it's very, very impressive, and that's something that you can check out. There's also the anime crate that I mentioned, and that's kind of work in process. It's incredibly fast for doing spatial joins between networks, and I showed it to my colleague, and he was pretty amazed because it gave us about 100x speed up on our joining the national data set. So that's something that's out there, but it's a little bit raw, and if you want to give it a go, by all means do so. We've written some basic R bindings to it. It would be great if we could have a Python interface to it as well. So that's like a software challenge if anyone's looking at integrating different network data sets. And the final thing, which is the not live demo, is just an example here that shows how concise you can be to get the active travel network for a particular city. So anyone who's got R installed on their computer should be able to run this code, and very quickly you can get an indication of the cycle network in relation to the driving network, which is different from most classifications of OSM data that just use the tags. This is using the tags in combination with estimates of how much motor traffic is nearby. So I think that is pretty much a good place for me to end. I don't know if there's going to be any questions. It seems like there's not time for a live demo, but if any of the questions are conducive to a live demo, I'm happy to do so. And there's lots of other work that we want to do in this space, including further extending the OSM Active package. And I just had a conversation with someone else at GISRUK who's interested in adding functionality for counting the number of lanes, which is the kind of a good process when you're building a particular project. If you can generalize it, then it might be useful for other people. I'd love to deploy these methods in other places outside of Scotland, and I think we've got a good foundation for doing that. Very quick plug, if you're interested in this kind of stuff, we're organising an afternoon hackathon at the University of Leeds on the 8th of May, and we're doing a 2-day workshop on transport data science on the 18th and 19th of September. So if that's your bag, check it out. It's all open source, and many thanks for listening. Hopefully there's time for a few questions. Thank you.
Thank you for that very important question. What does the live demo look like?
Okay, you set me up perfectly there. So here's one we built earlier. So yeah, this is the web application. This is actually we've got a production version, and we've got a development version of it. So this is after I've been kind of playing around with it, but basically the first thing that you see when you get to this website is a map. It's a map-based interface, and it works for all of Scotland. We have various layers here, so this one shows estimates of cycling potential under different scenarios. So Go Dutch is the default scenario, so we're talking about long-term strategic network planning. The coherent network is basically a kind of simplified network, but the main layer that the methods that I described in the talk feed into is this street space evaluation layer. And it's amazing how much data went into this thing, and at the end of the day, all it does is colours a road red, amber, green, and that is because the users need it to be dead simple. Basically, is there enough space for a cycle network? And I can show you the different options that you have. So if you're a transport planner, the first question that you want to ask is, am I going to have to remodel that curb line and change the layout of the pavement, which is going to make it more expensive, or can I just build it on the existing carriageway? So so the first option is you are building 2 one-way tracks, so you've got a cycle lane on one side of the road and on the other side of the road, and this will show you if you can just get away with building it, and it shows that a high proportion of the roads in Edinburgh actually are wide enough to just put a cycle lane in at low cost without doing additional stuff. So that's the live demo. I could speak at length. There's a lot of other layers in here, but that is the main layer, and that is quite new. I don't think we have that in England yet, and it's certainly new compared with stuff that I've done. And then you can verify that, and in fact there is a nice little light segregated cycle lane there. So that's the live demo. And I didn't set that question up.
We might have time for another short question.
Did I see that correct, that you can interact with it, like in the sense that I could like modify or add streets?
Yes, you got that right, but that is like an extension to that, which is the MPW. So the MPW is amazing in that it's basically a small transport modeling toolkit embedded in a web browser. So the short answer is yes. The long answer is go and have a play with it or chat to us after. This is also open source. It's developed by Dustin Holino, who is an expert Rust developer, and he's written that Rust backend that compiles to WebAssembly, and then there's a Svelte front end. So this is the design component. But what I've presented in the MPT is just evaluating the existing network and showing where the long-term potential is.
Thanks.
Okay, thank you.